Hi, good morning. Welcome everyone to yet another short video on this time on cost audit. And in this video, I'm going to cover a very important topic of your subject cost audit. The name of the topic is waste multiplier. Waste multiplier. Now, this topic actually holds a good 6 marks in your examination, and every alternate examination, a question from waste multiplier is recurring in the examination. So, let's see what is waste multiplier. Let me tell you that waste multiplier is mostly used in textile industry. It is a ratio which is mostly used in textile industry to understand the efficiency of a particular process in the textile industry. So before coming on to waste multiplier, let me ask you, do you know what is the input output ratio? Do you know what is the input output ratio? Of course, sir, we know what is the input output ratio. So if there's a process where input is 100, output is 80, process 1, process 2, process 3, input is 80, output is 60, input is 60, output is 40. In this case, the input output ratio will be 100 divided by 80, which is 1.25. For the second ratio, it will be 80 divided by 60, which is 1.33. For the third process, it will be 60 divided by 40, 1.5. So this is the input output ratio of a particular process which has the following numbers. Now if I ask you, what is the input output ratio of the entire process? Then what is going to be your answer? Sir, our answer will be that the input output ratio for the entire process is 100 divided by 40, which is 2.5 times 2.5 times is the input output ratio of the entire three processes taken together. Absolutely, sir. So 2.5 times is the input output ratio of the entire three processes taken together. Now let me change my answer, my question. Let me use another set of numbers. This time I have 100 units, which gives me output of 80 units. Then I have 70 units, which give me an output of 55 units. Then I have 60 units, which gives me an output of 40 units. This is another illustration which I am discussing with you, and I have different numbers. I have 100, output is 80. For process 2, this 80 becomes 70, output is 55. 55 becomes 60 and output is 40. Now the first question that you will ask me is, sir, how is it that 80 becomes 70? How is it possible? How is it possible that the output of one process doesn't become the input of the next process, but it decreases? And how is it possible that output of the process 2 increases to 60 for the third process? Of course, it is possible. In this case, some of the output which has been received in a process 2 has been kept in stock, because we have realized that this output is not saleable in market. Maybe there's shortage of demand in the market, so we have not processed the entire 80, but we have kept 10 units in stock and we have processed only 70 units. Sure, sir, got it. But sir, how is it possible that 55 turns into 60? Again, it is possible that we have purchased 5 units from the market, 5 semi-finished units from the market, and have introduced total 60 units in process 3. Or we might have opening stock in process 2 of 5 units and we have utilized those 5 units in the third process, and the input in the third process becomes 60 units. So of course, this is possible and this is also possible. Both the situations are possible. Now let us compute the input output ratio. So for the first process, it remains the same. For the second process, it changes to 1.27. For the third process, it remains the same. Now please tell me, what is the input output ratio for the entire 3 processes? Sir, 100 divided by 40, 2.5. So 100 units introduced in first process gives me an output of 40 units in the third process. So the input output ratio of the entire 3 processes taken together is computed by dividing 100 with 40, and the answer should be 2.5, which is same as the earlier answer of 2.5. Students, this is incorrect. So of course, we have introduced 100 units in process 1, but we have also reduced 10 units while infusing the inputs in process 2. So of course, we have created an output of 55 in the process 2, but we have not introduced the entire 55 in process 3, but we have increased the input required in process 3. So there is some disparity. There is some disparity in the inputs and outputs, and therefore it is not possible to compute the input output ratio cumulatively like this. This is an incorrect way of computing the total input output ratio of the entire process. Okay, sir, got it. So in a short while, I will tell you what is the correct procedure of computing the input output ratio for the entire process. Before that, I'm going to ask another question to you. Just tell me, if I ask you, let's take our first example. Let me ask you, in the first example, what is the output ratio? OO ratio. So first of all, you have to tell us, what do you mean by output ratio? What is OO ratio? So just like there is input output ratio which compares the input with output, I have output ratio which will compare output to output. For instance, output from process 1 is 80 and output from the last process is 40. So the output ratio of the entire first process is 2. Output of second process is 60. Output of the last process is 40. So the output ratio becomes 1.5. Output of the third process is 40. Output of the third process is 40. So the output ratio becomes 1. So meaning of output ratio is, how much output do we require from process 1 to get 1 unit of the ultimate output? Just like we use input output ratio to say that how many inputs of a product is required to be inserted in a particular process to get the desired output. Similarly, for output ratio, we measure how many outputs do we need to process in process 1 to get 1 unit of output in the last process. So for example, in this case, we need to insert 2 units of input to get 1 unit of the last output. Last output means output from the third process or the last process. We need to introduce 60 units of input in the second process to get 40 units of output in the last process. So 60 is the output of second process, 40 is the output of the last process. So this implies that we need 1.5 output from the second process to get 1 output of the third process. We need 2 output from the first process to get 1 output from the third process. And of course, in the third process, it will always remain 1 because output remains the same. So this is the theory of output-output ratio. How much units of output is required from a particular process to get one output of the last process. This is the output-output ratio. And this ratio is technically known as the waste multiplier. Waste multiplier is nothing but the output-output ratio. How many units of output are required from process 1 to gain one output of process 3? How many output is required from process 2 to gain one output from process 3? This is the output-output ratio or the waste multiplier. So sir, let's come on to our example number 2. Please tell me what is the output-output ratio of process 1? Sir, the output-output ratio of process 1 in this case should be 80 divided by 40. 80 is the output of first process, 40 is the output of the last process, so it should be 2. Your answer is incorrect. Again, the problem is disparity. If there is disparity between the inputs and outputs of two subsequent processes, you cannot ascertain the output-output ratio simply by dividing the output of first process with output of the second process. You cannot, because there are disparities between input and output. So 80 units of output of first process will not lead to 40 units of output in the last process. It will not. Reason is that input has been saved in stock while process 1 output is transferred into process 2. Then certain input was also purchased from the market. 5 units were purchased from the market or were utilized from the opening stock to attain the 40 units of output. So you cannot say that 80 units of output of process 1 will give 40 units of output of process 2. No, the answer is incorrect. So sir, how do we compute the output-output ratio or the waste multiplier when we have uneven data? The data is not even, the data is uneven. Uneven means there is disparity between output of preceding process and input of output of preceding process and input of subsequent process. When there is this disparity, how will we compute the waste multiplier? And this is what the examiner will ask you. Exam question will not simply be of a very simple case where inputs and outputs are common and you just have to divide the output. Questions will not come in this manner. Questions will come with a lot of disparity. There'll be disparity in output and input of the subsequent processes, and hence you need to learn how to compute waste multiplier or the output-output ratio in such cases. Okay, sir. Got the example. Now let us come on to a question. So I am at page number 2.7 of the module. Topic is waste multiplier. Let's read the definition of waste multiplier first. Definition is, please read the bold, italics and underline part. Waste multiplier is that quantity of output from any process which will be needed to get 1 unit of final output. Let's read the definition again. Waste multiplier is that quantity of output from any process which will be needed to get 1 unit of final output. So in layman language, I call it as output-output ratio. Let us come on to the question. Illustration number 3, page number 2.7 of the cost audit module. The following details of process-wise input and output are taken from cost accounting records of Sunny Cotton Mills Limited. a yarn manufacturing company for the year ended 31st March 2013. These are the processes which are given, and these are the inputs and outputs. So an input of 46,72,560 kgs will yield an output of the first process as 42,58,270. Then an input of 42,74,360 will yield an output of 39,76,400. Input of 39,48,250 will yield an output of 39,01,800. So on and so forth. The ask is that calculate the process-wise waste multiplier factors for the year ended 31st March 2013. Please remember that this question has recurred 2 times. Doesn't mean that it has not come after 2014. It has come after 2014 also, but with different numbers and different data. But this question itself has recurred 2 times in the examination, and it is bound to recur in future as well. So now let us start the computation of waste multiplier for Sunny Cotton Mills Limited. Please guys, you also write all this in your register. Computation of waste multiplier for Sunny Cotton Mills Limited for the year ended March 31st, 2013. Let's make a format. And it is not that you have to follow this format only. You can follow whatever format you want to follow. I'm just putting in all the processes which are there in this particular industry. Okay, our format is ready. So the data which we need to fill in the format is the input and output which we will receive from a particular process. 4672,560. You can quickly jot down all the data which is there in the question on your answer sheet. 3635 400 3580 880. Sir, there is a disparity between the inputs and outputs. कितना अच्छा होता अगर ये डिस्पैरिटी ना होती. हमको वेस्ट मल्टीप्लायर निकालने के लिए बहुत इजी चीज़ हम लोग करते. 48,58270 डिवाइडेड बाय द फाइनल आउटपुट 3580,880. बस हमारा काम बन जाता. हम आउटपुट रेशो निकाल लेते और वेस्ट मल्टीप्लायर निकल के आ जाता. कितना इजी हो जाता क्वेश्चन अगर ये इनपुट आउटपुट की डिस्पैरिटी ना होती. Absolutely, students, the question would have been much easier had this disparity not been there in the question, and the inputs and outputs would have been same. There would have been no problem in solving this question then, and we would have easily computed the waste multiplier without having need to calculate the loss percentage and output percentage. There was no need to calculate if this question did not have disparity between inputs and outputs. But now, when this question has disparities between inputs and outputs, what should we do? Simple. Can you compute loss percentage for me? Yes, sir. Very simple. Loss percentage is computed by subtracting outputs from the inputs and dividing by the output 4672560. I hope you got this calculation. Input minus output divided by input is the loss percentage. Yes, sir. We have done this in Inter and we know how to calculate the loss percentage. 8.87. Next is 4274. .97%. I hope you guys are also calculating the waste percentage simultaneously. Yes, sir, we are. Loss percentage. So guys, this is the loss percentage which we have computed for all the processes which are involved in this yarn manufacturing company. The loss percentages are computed by subtracting the output from input and then dividing the resultant differential with the input. This will give you a loss percentage. Now we have to compute the output. How will the output be computed? Please see this. Output will be computed by subtracting the loss percentage with the loss percentage. Subtracting the loss percentage with 100. So suppose if 100 units are inserted in process 1, what will be the output percentage? The output percentage will be 9.14%. How is it computed? 100 minus 8.86. Now be careful with the second output percentage. Now I want to use this output as my input in the second process. But sir, there is a disparity between the input and output of first and second process. Of course there is a disparity, and to rectify this disparity, I want this computation to be in parity and not be despair. Hence, I will use the output which is there in the first process as the input of the second process. And then I'm going to subtract, see this calculation carefully, I'm going to subtract the input multiplied by the loss percentage with the input. Are you getting what I'm doing? So the loss percentage will never change. Even if the input is 4274360, even if input is 502000, whatever is the input, the loss percentage will never change. And hence, if the input is 91.14, then also loss percentage will remain the same. If it will remain the same, then the loss will be 91.14 multiplied by 6.97%. So if I use 91.14 as the input, my output will be computed for the second process by multiplying the 91.14 input by the loss and subtracting it to the input. This comes out to 84.79%. Now I'll repeat the same method in the third process as well. 84.79 multiply by 1.18%. Are you getting what I'm doing? Is it clear? Yes sir, it is clear. I'm just making the input and output of two processes equal. By making input and output of two processes equal, the output and output of each process is comparable. If it becomes comparable, waste multiplier can be easily computed. So, the output of the second process will be 83.79%. Output of the fourth process will be, this is the fourth process, 1.10%. 83.79. $82.87. So 82.87, 82.87 minus 6.90, $77.15. Last process 77.15 minus 1.50 is the loss percentage of the last process. 75.99%. So 75.99% becomes the output of the last process. Now it's very simple. Now we have computed the outputs of each of the processes without disparity in the inputs and outputs. Now we can easily compute the waste multiplier by dividing the output of the first process with the output of the last process. So for example, the waste multiplier of the first process is 91.14 divided by 1.2. Second process, 84.79 divided by 75.99. 1.116. Third process, 83.79 divided by 75.99. 1.103. 82.87 divided by 75.99. 1.10. 77.5 divided by 75.99. 1.015. And the output ratio of the last process is always 1, because 75.99 divided by 75.99 always remain 1. So this is the way you should compute waste multiplier. And the waste multiplier, when there is a disparity between inputs and outputs, is not computed in a simple fashion, but is modulated a bit with respect to the output. The outputs are to be first. We have to make them constant. We have to remove the disparity, and then we'll be able to compute the waste multiplier at each process. So these are the process-wise waste multipliers which the question has asked me to compute. Now, in the conclusion, you can write that hence the process-wise waste multiplier is computed as under. You have to write all the processes and you have to write the waste multipliers to conclude your answer. So yes, this is an important topic. I hope you understood it well. If you have any questions regarding this topic, you can of course email me, contact me on the Facebook, or just drop in a message at the YouTube channel in which you are watching this video. Plus, for your benefit, I have uploaded all the notes of cost audit and BVM SPM at Agarwal Law House's website. Soon I'll also be uploading the solutions for the notes and modules, and you can take maximum benefit out of it. Guys, please don't hesitate in asking any questions, any doubts if you have on Facebook from me anytime, and I'll be happy to help you guys. Exams are near. I hope you are studying. Do well, study well, and make your teachers and your parents proud. All the best and happy studying.